All right. Thank you, Henrik. Thank you so much. It's really good. I've been at every PAC event so far. I think it's the most fun IT event altogether in the world. Forget about just performance, anything to do with computers. I think it's fun. I like the themes, love the videos. It's good to be here again. Okay, so as Henrik said, my name's Stephen. I'm based in Auckland, and as we've already discussed, in the past PAC events, both Mr. Stijn Schepers and myself have continually talked about this tool called Tableau. So, given the theme of Jurassic PAC, going back to the ancient times, the beginning, I thought I'd take a step back and do a back to basics introduction to Tableau for load test analysis. So that's what I'm doing today, mostly going to be hands-on demonstration. Very simple format. First of all, very briefly talk about what Tableau is. Then, why would you use Tableau for load test analysis? Why not just use your load testing tool? Talk about that. Then, hands-on demonstration, where I'm going to analyze some out-of-the-box JMeter results, the JTL file format, which I guess many of you are familiar with. And then right at the end, I'll show a little bit about where I'm trying to take Tableau further in our organization. Okay, so I was introduced to Tableau. So I think the person that introduced Tableau for the purpose of performance analysis was Richard Leake, who's an amazing performance expert based in Wellington in New Zealand. And ever since I was introduced to Tableau, I've probably used it almost every day of my work, not just for performance analysis, but for other things as well. Tableau's a company, and they make data visualization software. And they make several different products. The product that I'm going to talk about mostly today is called Tableau Desktop. And that's just a desktop application that you install on your laptop or VM or server or whatever you work on. And you use that to connect to different sets of data to explore and analyze them. Tableau's not built for performance analysis. It's used primarily by the data analytics and business intelligence world. It just so happens that it's very good analyzing any kind of data, including performance data. Now, Tableau is a commercial tool. It costs money, although it's a reasonably fair price. But it is worth checking out if your organization, it may already have licenses because of your BI team already has them. So it's definitely worth asking the question. Oh, there is a trial license you can use. I can't remember how long it's for, 10 days, 15 days, maybe 30 days. So that's what Tableau is, but why? Why use Tableau? Why not just, we've got a picture here of some charts from the out-of-the-box JMeter HTML summary dashboard. Why not just use that? Well, there's two key points I would make. One, and you've heard me say this time and time again, is that most load testing tools don't give us a way to view the raw data through a scatter plot, for example. And as I've said before, if you don't have access to the raw data, it's very easy to miss something about the system behavior and what's actually happening and to help diagnose an issue. So that in itself is enough of a reason for me to need to go and find a different tool in order to do that. But the other side of it is that most load testing tools have reasonably limited functionality around interrogating and exploring data to focus in on an issue and try different filters to figure out what's going on. And that's something that Tableau is very, very good at. I've used a lot of load testing tools over the years. And I would say that in general, most of them have fairly limited result analysis for the kind of level that I want to go to. And that's where Tableau comes along. And that's all the talking I'm doing. It's now time to do a bit of a demo. Okay. So I have a result file here. So this is out of the box JMeter results, the JTL file. It's just a CSV file. If I opened it in Excel, because of the extension, it's going to look funny, but we just edit it in good old Notepad++. We can see it's just a comma-separated bunch of values. First line is our column headings, the name of our fields. Really quite hard to see. Zoom in a little bit. and subsequent lines are just rows of data. But this text file is what we're going to be exploring in Tableau and connecting to. So this is Tableau, this is what it looks like. And the first thing you have to do before you can do anything is connect to some data. And you can connect to all kinds of data sources, all kinds of databases, even APIs like Google Analytics you can connect to directly and explore in Tableau, which is pretty awesome. I use PostgreSQL connection. I also connect to MySQL or MariaDB databases from time to time, SQL Server as well. But right now, we're going to do a simple text file connection. Going to wait for this to load. There's a little delay sometimes when I'm not on my VPN, but it will come. While waiting for that, we'll grab this path. Oh, wait. Here we go. Still frozen. It's going to come back any second. Here we go. Nice. Open. And now we are connected to our JTL result file. Simple as that. No other effort required. And we can see in the data source tab, we now see a table of all the different fields and all the rows and values from our test. So the first thing I want to do is I want to build a transaction scatter of the raw data. But before we do that, let's take a brief moment to look at the Tableau screen and all the different components of it. So in the data source view, we had all the different fields from our JTL file displayed as a table. All of those are either listed under dimensions or measures. And we won't go into the details of what's the difference between those is. In fact, I think in the most recent version of Tableau, there is no difference. They're just a bunch of fields. But the key point is that all of these fields, all of our columns in our JTL file can be found here in the dimensions or the measures lists. The next concept to cover is this idea of shelves or shelves. Now, in Tableau, a lot of the time, I'm going to take this off, it's really hot. A lot of the time you spend taking these fields and dragging them onto shelves to produce some kind of visual or view. And the most common shelves are column and rows, of course. We'll use those in just a second. But there are other shelves, such as color. So I can drag these fields onto the color shelf to change the color of what's on the graph. Or the size shelf. I can change the size of the points on the chart based on different fields. And we'll be doing that quite a lot today. The last concept that's worth pointing out is filters. So for any single field in any chart you've built, you can apply a filter. For example, often when you're looking at, say, percentile response time of transactions, you might want to exclude all those samples which there was a failure or an error. And so you could apply a filter to say only show transactions which succeeded. So filters, shelves, and these are our fields over here. Okay, let's move on and build our first chart. So the first thing I want to see is a scatter plot of every single transaction that occurred during my test. So the way I've designed my test is there is transaction controllers, and underneath those as children, there is one or more HTTP requests. So we'll start with the transactions. First thing we want to do is see a timeline of all the different events that occurred during the test. And the out-of-the-box results has this field called timestamp. So what this is if we go to the data source view, a 13-digit number. So it is a 13-digit Unix-style epoch timestamp. In other words, the number of milliseconds that have gone by since midnight on the 1st of January 1970. So I might just rename this to make it easier to remember. So this is the sample start timestamp, and it is in UTC time. So that's what JMeter will write out. If I take this and if I drag this onto the column shelf, and I pick the top one, I right-click and drag because it gives you the option to pick which aggregation you want. And the top one is the raw data. We now have a timeline of every single sample that occurred during my test. That's cool. We're getting somewhere. But this isn't human readable. I can't see what day this occurred or what time the test started. So we can take this further. So we can create something called a calculated field. These are the fields here and these lists that we got given from our JMeter results, and we can add to that. And a calculated field, if I go here, right-click our sample start time, create calculated field, you can enter an equation. So let's apply some logic to one of the fields we already have. We'll call the sample start date time UTC. I'm going to enter a formula in here. You don't have to take notes for it because I'm going to put it in the blog post. But all this formula does is it converts an epoch timestamp to a Tableau date time format. Right? If I take that and convert to continuous, if I drag that over now we have a timeline that we can see. It's the 23rd of September that this test ran, and it started at 8:26 a.m. One more step. I live in New Zealand. I don't live in UTC time. So I'm going to create another calculated field and call it sample date time New Zealand. The time that this test ran, we were 12 hours ahead of UTC time. And in Tableau, a date time, the value of 1 is 1 day. So we need to add 0.5. I like to write it as, 12 divided by 24, just to remember that's 12 hours. There we go, that's our New Zealand sample start date time. I drag that across. Now we have a timeline of when the actual test was run in New Zealand time. That's good, we're getting somewhere. Now, the next thing we want to see is how long did each sample take? Now, out of the box, the JTL file has this elapsed field. So if I renamed this into something more human readable, this is the response time milliseconds. That's cool. I could drag that onto the rows shelf immediately, and we get ourselves a scatter plot. Cool. We could use that if we wanted to. Now, in this kind of test with this context, I generally want to report seconds, not milliseconds. So you guessed it, we're going to create another calculated field. Add that by 1,000, the milliseconds by 1,000. Drag that onto the rows shelf and get rid of the millisecond response time. Okay, I like to change the shape to this plus. I think it's easier to differentiate marks, the different samples and how long they took. And now we're getting somewhere. Now we could add some color to this. So the label field from the JTL file is the sample label that you gave each transaction controller or request in your test in JMeter. So I'll call it the sample label. I drag that on the color shelf. It's now going to color every point based on the transaction the test was trying to complete. As you can see, there's quite a lot of them. Now you might notice that there's two of everything. So there's policy search by number, then there's policy search by number underscore TX. So that's because I've got a transaction controller and then a request inside it. And the transaction controller's, my naming convention is to put underscore TX at the end. But we don't need that naming convention because the JTL file has a field column called data type. If I right click that, and I'm going to apply a filter based on this. So if I click show filter, it adds it as a toggleable item here. Now in the JTL file, if a sample has the data type text, it is an HTTP request in this case. If it's null or there's no value, it is a transaction controller. So here we want transactions, we'll exclude requests. There we go. So now we have a scatter plot of every transaction event during my test, showing us how long it took in seconds. If I put my cursor over, I can see details. Now, I've currently colored it by the different sample labels, but you can color it by anything you want. For example, success is another field. Did my request succeed or did it fail? If I drag that onto the color shelf, we now see whether the request succeeded or failed. I'm going to change this color scheme here, edit colors. Let's say false is a nice dark red and true is a light green. Now, keep in mind, if you use red and green for pass and fail, which I do often, there are many people who are colorblind, and red-green colorblindness is the most common. So make sure that your red and your green colors have a different darkness. Separate them. So here we can see we ran a test, and you can see there's something interesting happened. Near the start of the test, there's a six minute window or so where there's a lot of failures. That's interesting. We found something out. Now, another scatter we could do, if I duplicate this one, which is quite handy with this icon at the top, I'm going to do a request scatter this time, and we're going to find something new out. So we'll just untick the null and tick the text. Now we see a scatter plot that looks very similar of every request that occurred during the test. But instead of success, why don't we color it by the HTTP status code that came back from the server? That's what this response code field is. Let's just call it HTTP status code. I drag that onto the color shelf. It's going to not look so good first, but we're just going to change the colors a bit. Now, null, what does that mean? It means that there's no status code. So for JMeter, that generally means a connection could not be established. Maybe there was a timeout, or maybe the network transmission was cut off early. Right? So that's a bad thing. We don't like nulls. So we'll color that like a dark gray. 200's all good. Let's give it a light green. 201 also good. We'll give it a light blue. The 400's, we'll give them different levels of orange. Purely aesthetic. And the 500's, we'll give it different reds. Light. Then I'm going to sort these so all the failed ones are in the front so we can see them more clearly. So click sort, ascending order, and then I'm going to pick manual top. There we go. Okay, so now we have an interesting chart, and we've found something else out. So during this period where everything seemed to fail, we're predominantly getting 503 or service unavailable errors. And there were some bursts of null, so connection issues as well. So, all right, the last thing I wanted to point out is I talked about interrogating data. We're starting to do that already, but we can also apply this zoom control. So with this particular tool here, I could say, I want to focus on this particular period here that was failing, and it zooms in. Oh, actually, I want to look at this period here, and then zoom in again. It's very powerful. You can drill into particular events and what was happening at a certain point in time. All right. So those are scatter plots, and I'm going to move on now. I know that Stijn Schepers in his talk is going to talk exclusively about scatter plots and raw data and how powerful that is. I'd say even if you get to this point and you're producing scatter plots with raw data, you're probably doing better performance analysis of load test results than 99% of performance testers. It's a good starting point, but we can take it further. So, another really common view that we need is a percentile response time chart. So we'll call this our percentile. By percentiles, in my experience, most non-functional requirements are defined, and also it's a good measure of user experience in some cases, as long as you capture the raw data as well and look at that. So here we go. I've dragged all my sample labels across, and I'm going to filter. I only want to see transactions, not requests. And if I take response time second and drag it onto the column shelf and pick average, we have something. This is a bar chart of the average response time for each transaction. That's a good starting point. And to turn it to percentile, all I got to do, pick this little down arrow here, change the measure from average to percentile, and we'll pick 90th percentile. So we've already achieved the basic outcome. We have a 90th percentile response time chart. But what if you want a single chart where you can say, I want to look at the 99th percentile or the median, the 50th percentile? How can we do that? If we look up here, this thing up here is just it's an equation, the percentile function, and I'm passing in my response time. And then I've got this hard-coded value here. So what we can do is replace this hard-coded value with a user-defined variable. Now in Tableau, those are called parameters. So I'm going to create this parameter. I'm going to call it percentile value. I'm going to display it as a percentage with 1 decimal point. I'm going to give it a range of 0 to 1. And there is our parameter here. It's just like another field. I can right click it, show the parameter control. I'm going to change it to a type in. There we go. So now at the moment I can type in 0.95, that's 95%. It doesn't do anything yet. I need to connect it up to my equation. All I've got to do is type in here. And voila. We now have a percentile response time chart, and it's showing 95th percentile. Now it's showing the median response time. It's sort of responsive to whatever I put in here. And also, one tip is if you control, click, and drag something, it duplicates it. It leaves it where it is and adds it somewhere else. So if I drag this onto the label shelf, we now see the percentile response time above each bar, which is pretty handy, right? Everything on that you see with any text, you can format it. So if I click this, go format, I can change this number to have one decimal place, right? I like to keep it as simple as possible. So we've taken it further. We're getting pretty close, but I think we can do better. So the first thing is, a lot of the time, I want to see the slowest transactions at the top because they're the ones I care about. They're the ones with the problem. So Tableau has this handy little drop down at the bottom here. If I click it, it's just immediately sorted them in descending order. Very handy. I only just found out about this recently, so definitely use it. That's cool. Now we see what the slowest transactions are and the ones we need to focus on. But another thing I often do is I don't really care about anything that is really, really quick. So we can apply a filter to say only show those transactions which took longer than a second, 90% of the time. So to do that, I can just pick my percentile response time field, click filter. I'll say at least one and click apply, and it's done. And what that's done is it's added this filter to my filter shelf here. And there we go. The last thing about this chart worth pointing out is this view up here. You can change your charts to fill the entire view of the screen if you want to, as well as fit the width or just the height as well. It'd be handy. So that's percentile response time, also very handy. Two more things to look at. One is, let's say you run a performance test. It's really important that you check you applied the right load, right? So we're going to do a transaction throughput view. Okay, so once again, we'll get the sample label, drag it on the rows shelf. We're going to filter, once again, only transactions. Now, out of the box, Tableau, doesn't matter what your data is, there'll be a field called number of records, which is provided by Tableau. I can use that to show how many times something occurred. I can pick the sum of the number of records. Yep, and now it's showing how many of each record occurred, and we can add a label to make it a bit easier to follow. Now there's a heck of a lot of calls to the home page. That's something weird, and we don't care about this think time object, which was a mistake that shouldn't have been reported, so I can exclude it. So that's one thing, but when I run a test and I want to look at how many transactions I completed, I usually focus in on each scenario. There's a key step. So if I'm creating an assurance quote, it's that final step where I get the quote. I want to know how many times did I successfully do that. So what I'm going to do is just that. So with the 3 characters at the front, that tells me which scenario this was. Now this is a browser scenario. So I'll just pick the last transaction. This one is all about creating a customer. So we're going to pick the step which actually creates the customer. This API is about creating a home quote, beginning a quote as well. This one is about also creating a quote, so we're going to pick that transaction. This one is about issuing a policy. And the last one is also about creating a claim, a quote. If I right-click, keep only, there we go. That's not a lot, doesn't look like much, but this is a very, very helpful view. I'll probably have an Excel sheet or a Confluence page somewhere with a table which has my target throughput for each scenario, and I'll compare this to that to see if I applied the right load. Now, there's another, I might have to, another kind of throughput you might want to see is the number of requests that occurred over time. So we'll bring back our timeline view. But this time, we're going to change the sampling period to a second. Now we can use our number of records once again, pick the sum. We'll call this requests per second. Once again, we'll apply our data type filter just to show requests. Oh, this is interesting. During the period where things were failing, we had almost 300 requests per second at times. That's pretty bad. And that's because of the design of my test. So the way that these tests are set up is you go to the home page, you log in, and then there's a business loop. Inside that business loop is the pacing, or the constant throughput timer. But what happens if the home page fails? It doesn't get to go to any constant throughput timer. So it just smashes that home page as fast as it can. So that's what happened there. That's throughput. Now, the last thing I wanted to cover is failures and errors, right? So if something fails, you want to know which transactions failed and how often, and get more information about that. We'll call it a transaction success rate. Again, get our sample labels. And like before, we'll put in our filter. Just transactions again. We use the sum of the number of records like we did before. And all we're going to do is color it by success. And notice how it's remembered my color scheme from before, which is handy. Now this is cool, but it's a bit hard to see because the home page happens so often, it's kind of blowing all the other bars out of the water and we can't see them. So what if we wanted to see the percentage success rate for each transaction? Without going into detail, Tableau has this thing called table calculations, and it provides some out of the box. So if I just click here, quick table calculation, percent of total, and then compute using table across, voila. Now we have a chart which shows us the percentage success rate of every single transaction we tried to complete during our test. Now we're getting into some detail. This home quote failed 100% of the time. Funny that. The home page failed more than 99% of the time. That's also interesting. Now the final view I want to show also looks at failures, but this time we're going to look at the requests and the status codes again. Right? And I want to see the sum, the number of records per minute. I only want to look at requests. I'm going to change it to a bar chart. And we're going to color it by the HTTP response code that came back from the server. And this is a very informative chart. So you see everything's succeeding. There's not very many failures, right? And then at a certain point in time, there's a whole bunch of 404s start happening. And then after that, for about 5 minutes, we get 503 responses to pretty much every request we send. Now, I'm not certain, but what I think happened at this time is that there was a deployment. And initially, nothing was available, but then the web server was available, but the downstream application wasn't. So that's why we get 404s initially, but then when the web server was deployed, then the application wasn't ready, so it would give service unavailable errors. Then after 5 minutes further, the application comes back online and everything recovers as we hope it would. So those are the only charts that I wanted to cover in this presentation. So if we just quickly go back to the slides. Oops. Give that a second. It likes to have a delay from time to time. When my computer's not on the VPN, it does not like life. Here we go. I'll just quickly get to the next bit. Okay, so I've tried to take Tableau a little bit further. So today was all about the basics, but what the thing about Tableau is not everyone has a license and not everyone knows how to use it. So what I've done is I've created this Node.js application again, like Srivalli did, called the Stash. And the idea is you can take some JMeter results and you upload them. They get put into a PostgreSQL database. And from that, we connect Tableau to look at the results, right? But the thing is, we've got different teams from around the organization all putting their JMeter results in the same PostgreSQL database. that opens up a whole bunch of possibilities around collaboration, sharing results. The other thing I'm doing is I'm utilizing Tableau Server. So you can access the Tableau workbook in a browser, which is what we're going to do here. It doesn't have all the functionality of Tableau Desktop, but quite a lot. So I published this workbook. I created a whole bunch of views for looking at different things. It's already created so that anyone can use it without having to know Tableau deeply. You can go in, and this particular dashboard we're about to look at right now is supposed to give just a summary view of over multiple tests and how things are tracking. And it's completely interactive, and you can modify things any way you like. I think it's this obviously an MVP, very early days. It's been really helpful in building that collaboration. I work with people in different time zones around the world. So I wake up in the morning. There's some people who've already run some tests while I'm sleeping. They've uploaded it into the results repo. I can go in, do some analysis. It just makes that so much easier. So I think it's providing value. I hope so. And if it isn't, it definitely is providing value. And I think it will provide even more value once we iron out the kinks and see where we can take this further. But yeah, that's all I wanted to cover today. Like I said, Tableau, there is a trial license you can use. And in my blog post, I'll be providing all the formulas, all the step-by-step instructions to create any of the charts that I created today. This was more about just demonstrating what's possible. That's it.
Great. Thanks so much. So I really enjoyed it, to be honest. So I have questions, but I think there's all the questions from the audience as well. Yep. So one question is from Medham. Let me first, before we answer the questions, take advantage of the fact that we have, I think we have Stijn, which is connected. I think it's quite early. Yeah, it's working quite early. So I'm going to enable the webcams of Srivalli as well. Srivalli's connected twice. So I'm going to enable Srivalli twice then. And yep, so now we're all connected. Let me share the view. Here it is. And let's start the Q&A then. So
hey, Stijn. Good morning.
Hi, everyone.
Good morning,
Hi,
Stijn.
Scott.
Hey, Scott.
So I have questions from the audience.
Hey, how's it going?
Jump for the questions from the pack members. So here you, if you run a distributed test with multiple load generators, how do you are going to do the analysis? Is it going to be the same way? I mean, here I guess your test was quite small because you had I didn't pay attention on the size of the file, the results file. But how would that would the process of analyzing be the same if I have, like, say, a 50 gigs results file? Would that be a challenge, or what is your experience on that?
For looking at an individual test, you can go to multiple gigs, and there's a couple of options there. Connecting to just a text file directly, you might find it's pretty slow if it's 50 gigs, right? But Tableau has this inbuilt internal database called an extract. So you can extract that data into a Tableau extract, which is like a special Tableau database, which is really high performing. And then you can use that to interact with the data. That's probably the best way to do it, and it's out of the box. Another way you could do it is you could insert that, like I do, insert that JMeter result data into a database and tune that database to perform the way you want it to. It can be a bit tricky to set things up and have the right indexes and so on, but okay, I guess this the kind of sizes that I'm used to analyzing, somewhere in the between 10 and 150 meg sort of range. And in our Postgres database, we've got 6 months of test results with those kinds of sizes and multiple tests a day. So it's pretty good. And even if it takes a minute or two to render a really important chart, that's okay.
Cool. I have a question, but I think if you wanted to have a open source version of Tableau, would that be R, or would you have any suggestions?
So Srivalli spoke about something called, and I know Scott has done a lot with it as well. There's a programming language called R and R Studio that you can use. It's not exactly like Tableau, but from what I can see, there's a bit of a learning curve, but once you get it, it can do anything that Tableau can do and probably more, if you're willing to put the investor time to get to know it. Maybe Scott can talk more about that.
Scott, please.
Next up. It's the next up. Everything in the presentation next was done in R, so it's very, very powerful. Assuming I can get Blue Jeans to work properly.
So I think the other question that we had has been answered because you showed us a dashboard. So he said the question was, is Tableau able to compare two data sets, two results? I guess so. Just a filtering, just a case of putting the right filter, and I think you can do it for sure.
One thing, I do that. That's the main reason I put all my results in a database, is because I want to have lots and lots of results to compare them with each other. And all you've got to do is add a run ID as part of your results. So I just log a run ID for every single sample. So it's really easy to figure out which sample belongs to which test. Yeah.
Okay. So I had questions. So you showed us stash or mustache or Movember. I don't know how to name it. That's that portal. I hope that you have built an API where your pipeline after a run takes the results from your JMeter scripts, push it through the API, and then you provide the link in Slack or in Microsoft Live or whatever you use, and so then the tester doesn't have to get the link of the Tableau dashboard anymore. So do you have an API to import your data?
I actually think I do have an API, but it's not used at the moment. But what I am, I have to admit it's an MVP. The plan is actually just to have it so that it listens to file shares, and you can configure as many as you want. And whenever any file gets dropped in, it just consumes it and processes it. I think that's probably going to be the easier way to do things, given the huge size of the files.
And sorry, I'm looking at the connected. Stuart Moncrief, by the way, hi Stuart. It's great to have you connected. He was part of our first PAC in Scotland. So we miss you, by the way. Come and join us the next time. So he said that the licenses for Tableau is about $70 a month. Is that the desktop version? You showed us the distributed Tableau server. Is this going to be the same price, or is just for the audience? Is there a difference of price? Is to figure out if there is a significant investment for the organization to implement what you just showed us? That will be my first questions. And secondly, is that you built those awesome dashboards. I really like those dashboards, by the way. What is the journey to build all those dashboards? So I would say that I'm a new performance engineer. I just started to take the role in this company. How long would it take me to have the same setup that you just showed us?
Okay, so we'll start with the first question about I'm not an expert in the licensing. So everything I did was with Tableau Desktop, apart from the very end where I showed all the dashboard on the server. Server's a bigger investment, but there's a different model, right? Because you pay for a server license, I believe, and then you also pay for viewer licenses for each person who wants to view. But those are much cheaper, I think. I might be completely wrong there, but it's a different model. The second question is, what's the journey? That's tricky, isn't it? Because there's not many people, apart from Stijn and Srivalli and I, and Scott, I know you know Tableau as well, who use Tableau on a regular basis. And so I guess that's why I did this session, because there isn't really a beginner's guide to Tableau and analyzing low test result data, right? And so my blog post is going to be step by step how to set it up. And I would say start with the scatter plots and build out the charts you need as you go. Yeah. And once you've done it, you don't need to build it again, right? You've built the workbook, and if you can connect out different data and refer to what you've done, or just reuse the same workbook and just point to different sets of data.
Yeah. Is there like a similar to Yeah, just sorry, Scott. I'm just going to ask one question, and I will let you ask your question. There was a thing just coupling in my mind. So I have to ask it, otherwise I'm going to forget it. So in Grafana, you can create dashboard, and then you can export the settings of the dashboard in a JSON format. So once you have to, I don't know, to generalize the usage of the dashboard, you can easily import, export the settings of your dashboards. Can you do the same thing in Tableau, where you have built all the setup of graphs and things to collect and visualize the data? Is there a way to easily export it like in a sort of config file, and then you have to sort of drag and drop it, and bam, you got the dashboard ready?
Yeah, that's what I mean. It has its own TWB Tableau workbook format, right? So that's one, and you can configure those in a way that points at a relative path of data. And yeah, it's the same thing. It's just like saving a file which has all your. So the thing I was building today was a workbook and with lots of worksheets, and that's the thing you can save. And if you have server, you can export that to the server as well, which makes it available to other people.
Okay, cool, awesome, thanks. So Scott, you had a question.
Yes. It's not so much a question, it's more of a statement, but one thing I enjoyed working with Tableau when I was working with it a lot is it forces you to actually look at your data before you visualize it. And once you start getting used to the idea that data can both be long or wide and long, and how to pivot between those two things conceptually, it becomes a very, very powerful tool. But sort of visualizing the stuff on the screen, and you've got a lot of it, and you can scroll through and just pick up trends by mark one eyeball. It's a very powerful thing to do, and I think a lot of performance testing tools in particular kind of hide that sort of stuff. So taking your analysis out of the tool, dropping it into something that's purpose built to do that, it's a must if you're getting into performance testing. Don't trust the analytics from the tool.
Stijn, you had a question?
No, it's just adding some value here. Great talk, Stephen. I loved it. It's indeed Tableau, and doing some more time in your data analytics is so important. I see lots of people spending a lot of time in scripting and then the analytics. Oh yeah, that's at the end. Well, I really would encourage people to actually flick that around and spend way more time in analytics, because that's where you add value. And having a tool like Tableau to be able to compare indeed 20 runs or 50 runs or 60 runs like we do, it's so powerful. And when you go into DevOps and when you do automation and you run lots and lots of tests and lots of commercial toolings, they are actually not so good to compare 2, 3, 4, 5, let's say 20 runs. And that's where Tableau is really handy. And it seems sometimes to be a bit of work to actually get those dashboards there. But once you have saved them, you can just reuse them, and they're nearly all the same, because performance testing data is always the same. Depending on what you see, you will customize, zoom in, and look at the issues. But once it's actually not too much time to create those, and I hope that Stephen will save a template that people can reuse from Tableau, so you can just download it and reuse what Stephen has done, and that will also help people to get into it.
Good idea.
And of course, listen to my talk when the sun is shining here and not so early morning.
And one note from myself, when you were starting to build a scatter graph and say, oh, he's got a shot. Oh, awesome. And you did not show us the tornado graphs. I was expecting that, Stephen, but next time. But if you can give us a small tutorial in your blog, that would be great. To moving on to tornado graphs, because I love this type of graphs personally.
Yeah. Okay. I wanted to keep to the basics.
2 questions, and then we will have. By the way, Arinder, do you have any questions for Stephen? Scott?
No, just more of a comment kind of thing. Yeah, tornado graphs. I've been trying to get those graphs.
All right. I'll put them in the blog.
Question.
That easy and hard.
Hendrik, do we have time for one question?
Of course we have.
Okay, so I was just thinking as you were presenting about integrating like Tableau, pulling the results from a NoSQL database, because what I'm currently doing is when I run a test, sometimes I need to pull data out of the Cosmos DB, and currently like I run a script which converts the JSON array into like a CSV file, and then I'm loading into Tableau. So I was just thinking if there is a quick way to directly integrate like with
I think that I know that Tableau has a MongoDB connector, so MongoDB is another NoSQL database, as far as I know, and that just handles it for you. So you don't have to worry about converting data. You just connect and retrieve, as if it was a
like can you usually load an array of JSON and in a file and visualize it? Okay, cool.
Yeah.
And does it also compatible with because there was a question about it with InfluxDB database? Is there like
It wasn't a couple of years ago when I was investigating. I'm going to have a little look right now, but.
And while you're looking, I have another question that has been asked by the audience by Jesse, who asked, are you combining server and DB logs with the load test results in Tableau to allow to drill down on problems?
I'm not combining them all as such, but I do probably half the time. I'm analyzing application and server access logs, and that's in Tableau. I do that all the time, but I haven't got a complete combined run a test, pull the logs, put them all together. That hasn't happened yet. It's a nice thing to aim for.
But you're planning to do that?
Yeah, it sounds exhausting. I'll give it a go.
Okay.